Hello students, and welcome to the final video of this lesson. In this video, we're going to start covering how we can actually continue to work with the fundamental theorem of calculus and kind of tie in some of the old material so that we can continue to unpack calculus and tie everything together. So let's get started. So in our first question here, we're going to just say, okay, what is the value of the integral from -3 to 1 of f prime of x dx? And we're given this table over here on the right. What you want to keep in mind is that we have f of x, f prime, and f double prime. Whenever we're going up, we're using antiderivatives. We're going to be finding integrals. So this question actually isn't too difficult when you think about it, because what I want to do is I want f of x, because that's the antiderivative of f prime, evaluated from -3 to 1. And so if I make these substitutions, I'm going to get f of 1 minus f of -3. All right, and let's actually write out what these are, because we're given this in our table. So f of 1 is going to be -2 minus f of -3 is 4. So this comes out to be -6. So that's what I mean, is that just knowing the concepts are more important, because you notice that the mathematics behind this, the arithmetic, actually doesn't come out to be too difficult. So you're going to do the same things here in 2, 3, and 4. Just keep in mind, if we have multiple, we're going to be getting into the properties of integrals in a future lesson. But just keep in mind that if we have the integral from -1 to 3 and we have addition happening, it's just the integral from the first part, and then we just recopy the integral -1 to 3. Same thing, if we're multiplying, we just multiply, we do the result, we kind of just bring this 3 to the outside, and we multiply everything by 3 in the end. So see if you can do 2, 3, and 4 and get the same answers as me. All right, here are our results. In our first problem, number 2, we're gonna get an answer of 3. In number 3, we got an answer of 6, and number 4, we got an answer of 17 halves. So it's really just, again, you take a step up, you substitute in the values, and you calculate it from there. So we have a couple more problems here. Let's move on into this question number 5. What is the equation of the tangent line to the graph of f of x at x equals 3? So remember, this is old stuff where we're finding tangent lines. There's two things that you need. You need a point and you need a slope. So let's get that starting point here. So we're finding it at 3. So we want f of 3. And again, we just need to grab this from the table. So f of 3 comes out to be 1. And then we need the slope at 3. And in order to get the slope at 3, we need the derivative, which we're given. So we're going to say, okay, what is f prime of 3? And again, from the graph, or sorry, from the table, f prime of 3 comes out to be 3. So now we have enough information to actually just come out and write our tangent line. That's going to be y minus 1 equals 3x minus 3. Remember, you don't need to simplify, just write in point slope form and you are good to go. And let's move into our final question here, number 6. We want to use this equation to find the value of f at 3.1, okay? And then we're going to say, is that an over or an under approximation? So you're going to have to remember, okay, how do we figure that out? But let's actually find this approximation. So I'm going to substitute 3.1 up here into x. So I'm going to go y minus 1 equals 3.1 minus 3. So let's simplify this. I'm going to add 1 to both sides. So I'm going to get y, which is f of 3.1. And I'm going to get 3.1 minus 3 is 0.1. So 3 times 0.1 minus 1. And I'm going to get, sorry, we're adding 1 to the other side. So that's going to be plus 1. So 3 times 0.1 plus 1 is going to be 1.3. So that's f of 3.1. All right, so now we have to say, is this an over or an under approximation of the exact value at f of 3.1? And in order to get that, we need to determine, all right, what is exactly happening to the concavity at 3, f of 3? So is it concave up or concave down? In this case, we know that the second derivative of f of 3, so second derivative at 3, is -1, which is less than 0. So it makes it negative. So that means that the function is concave down at x equals 3. Therefore, we know that this approximation of 1.3 is going to be an over approximation because we have our function, we have our parabola, it's concave down, and we have our tangent line. So if we go anywhere to left and right, it's going to be a little bit over that parabola. So that's how we know it's going to be an over approximation. All right, and that right there is going to conclude this lesson. Hopefully you got everything down as we were going through it. Of course, if you need some refreshers, you need some tips, if something isn't clicking with you, make sure that you guys do reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.